Ladies and gentlemen, I am aware that part of my presentation may overlap a little bit with the following speakers. I will try to reduce as much as I can the overlaps, but there are some spots that are indispensable. First of all, I think that we have to think about when we propose a research to the study design that should answer a specific question and the way in which we want to prove it. And this is something to do also with the sample selection and with your intention to show the direction where the study should go. Another point is important is the data collection, and finally the analysis of the data. The results finally should give us an answer in terms of the efficacy or in terms of other parameters. And at the very end, the conclusion should be reported to someone who may be interested on that and should be useful. The study design, however, in any experimental study has the essential question to define the outcome. And related to the outcome, there are the variability and all the consequent plan analysis. The sample collection implies an adequate sample size, and if you have a specific sample size, the type of sample size. What data should be collected, and the analysis of data should obviously imply the results referred to the hypothesis test and the different significance or conclusion. So we have a sort of stepwise considerations to make. When you look at the experimental question, the two questions should be what and how. The sample selection, who and how many, and after the collection of the data, the analysis should give us and should tell us if there is an effect and to whom. My suggestion is to look at the website of the concert checklist, where you can find useful suggestions. And for the number 6 criteria concerning the outcome, the essential point is clearly define the primary and secondary endpoints and the outcome measures. We have different types of outcomes. Binary, in case you have an alternative. For instance, a group that is bleeding versus no bleeding, or you can quantify the blood loss, but obviously you have a threshold below and above this threshold. Or you may have a continuous variable. The example could be the blood loss expressed in milliliters, the time of mechanical ventilation, the length of stay in the ICU, or the time to event, the survival, with the hazard ratios that can give us the answer to our question, or ordinal or nominal, for instance, the local pain. We do have a mild, a moderate or severe pain, or we can quantify this kind of variable in terms of pain scale, and this scale is a often semi-quantitative scale. If I have to give very broad suggestion concerning the kind of outcome and the potential test that could be applied to them, roughly when you have a dichotomous variable, the t-test can be appropriate. When you have a categorical variable, when the outcome is continuous, the ANOVA or the linear regression analysis can be applicable, and so on. These are just examples. However, we can have differences between the different groups that in a way or another are related to our primary and secondary outcome. And in my opinion, we should always take into account the actual effect when there is a difference between the groups, and we have to look at the chances, biases, and confounding factors. And when you apply your statistical analysis, you have always to keep in mind that these are determined at the very end to just understand if there are some differences between the observed difference and the groups that was likely due to chance. What is the null hypothesis? In all experiment, we have an initial belief. When we toss a coin, for instance, you believe that there was a 50-50% of chances of a head or the cross. And always you need to set up the null hypothesis and that can be rejected. And the null hypothesis can be rejected when there is a difference, and may not be rejected when there is no difference between your groups. The definition of the p-value concerns the probability of the observed results under the null, and if the probability of the event is sufficiently small, the difference is likely not due to the chance, and we actually have really an effect. The p-value is small enough. We call the effect statistically significant, and if you look at something that is just at the border, a p.05, in case of this kind of difference, there is not really a statistical significance if the value is immediately above that. And the two groups are not significantly different, but we cannot say that they are exactly the same. In these cases, we fail to reject the initial null hypothesis, and we do not accept that null is true. The other confounding factors may be related to other consideration. In a scenario where you compare treated patients and not treated patients, you may have a difference because one of the two groups may be, and this is a bias, healthier than another since the baseline. However, the real point is that if you look specifically and only to the p-value, this doesn't tell us if the hypothesis that has been tested concern the chance or to the biases or confounding factors. So, first of all, what we have to do is just to decide the null hypothesis, and carefully you have to start to state and define our endpoints. And after that, if the observed results are indeed sufficiently rare, we have to reject the null hypothesis. But try to give you some examples and be more specific concerning the outcome measure. We need to explicitly define these outcome measure, and we do have a time point which must be our primary interest. This should be measured previously and develop validated tools to measure it, and if available, this validation tool may help to reduce the biases that can be attributable to one of the two groups. The outcome measure must be clinically relevant and meaningful, and the other important point should be capable to be measured by all the participants. If I have differences in the participants to the study and someone is not able to measure a given variable, it is obvious that I start with a heavy and important bias on my study. Ideally, I know that this is difficult at times to be accomplished, that this outcome measure should be measured by assessor who should be blinded to the treatment allocation. But this is not always the case, and we know that there are many reasons for that. The primary outcome measure should refer to a measure that maybe should be easy to measure in order to be very comparable in the different participating centers, for instance, and should be clinically relevant, as I said. I think that the important point is just to keep in mind that you have to calculate, and the following speaker will address this issue much better than can I do, should be the fundamental prerequisite to calculate the sample size. Secondary outcomes may be, for sure, outcome of interest. Think about the clinical or economical implication of certain outcomes. However, you have always to keep in mind that as soon as you have to calculate your sample size, you have to look at the primary endpoints and not secondary endpoints. There are also some other possibilities of finding out surrogate outcomes. The surrogate outcomes are a sort of intermediate outcomes that are related in a way or another to the outcome of the main interest. For example, if you address the importance of the biomarkers related to the predictability of unfavorable outcomes such as mortality, and in general, these are not always so easy to be collected, but anyway, very useful. The real point is that we can have a valid surrogate as soon as you can receive an help to accurately predict the outcome of interest. The point that has a lot to do with the sample size determination is, again, the primary outcome. I don't insist on this because I think that the following speaker will address quite well all these major points. Just to remind you that the power means that you want to have the ability of the study to detect the true difference between the measurement arms, in generally set at 80%. But if you have multiple primary outcomes, it's better to consider 90%. I will skip this. I think this is much better. But I want to give you an example just to understand why at times you may fail a study, also important studies. In general, we should have a starting point for the primary outcomes. We should know from the literature or from your personal clinical experience what to look at. If a phenomenon has a certain prevalence in your unit or in the literature, this could be the starting point. And you have always to keep in mind that as soon as you have the study and you see that the event rate that you are expecting is lower than that you have estimated in the sample size, the implication, unavoidable implication, is the increase of the study power. I will give you a specific example that concerns the choice of the primary outcome and how this choice may have a detrimental for the final results. I want to show you the study coming from one of my close friends, so I'm not biased against him, who is Andres Esteban, concerning the application of non-invasive positive pressure ventilation as a mean to resolve the post-extubation failure. In that study that was not a double-blind, but was a multi-center randomized trial, he enrolled something like 221 patients, and the primary endpoint was mortality. Well, he calculated mortality in a very, I would say, arbitrary way, and he started from a personal hypothesis, not looking at what was reported previously in the literature. In these cases, the only study that was similar to the one that Andres Esteban published subsequently in the New England Journal of Medicine, the study published in the JAMA by Keenan, reported that the mortality rate between those who received a conventional treatment and non-invasive ventilation was indeed 9%. So, in my opinion, this should have been the starting point for calculating the sample size on this primary outcome. But if you recalculate addressing the difference in mortality reported in the study by Andres Esteban, based upon that 9% difference, indeed, the number of patients that were needed per arm was much higher, 400. So it means that in these specific cases, the study was certainly underpowered. The type of measure may influence the required sample size, and in general believe that you may get, when you have a primary outcome, this may influence the importance of the sample size. But again, sorry if I overlap a little bit with your presentation. The other point is look at the diagram that can show to the participant what went on in your study and which stage all the different patients have been included. If you look at these, this is again based upon the analysis of the primary outcome, and all the flow of the diagram should be conditioned looking at these primary outcomes. Obviously, this diagram, which is essential for giving right away the message to the readers and to the reviewers, should report the flow concerning the eligible participants, the eligible patients, the numbers likely to be recruited, and the likely participant losses, and the estimated number for the primary analysis. I will conclude, and I apologize again if I overlap with the following presentation, not intentionally, that you have always to carefully choose the primary endpoint. Well taken into your mind, which is the essential, what is the answer, what could be the potential answer to your main questions. You have always to think that when you choose a primary outcome, that is mortality, very, very often the number of the patients that you have to recruit in your sample will be larger, much larger. And in general, this is another implication that you cannot, based upon a single center study, the recruitment of such a larger population. And in this case, it is indispensable having at least a multi-center, if not a multinational trial. Don't forget that the calculation of sample size should be based upon the primary endpoints. And don't forget that also the secondary endpoints that obviously should not be the essential to calculate your sample size, should be relevant and related to the primary outcome, especially if these are clinical or economical. I put into the end of my presentation some references that you can find in the web, and essentially you can just refer to them for having some additional information. Thank you so much.